Good evening, grade 8s. It's math game time. So I did mention I was going to be looking at getting a game for the classroom every week, and it's going to be a math game where we can try to use our skills and apply our math concepts in a fun and engaging way. This week I was walking home from school and I saw this game. It's called Mancala, and it's an ancient African game that's still being played today. And it comprises of these marbles or just stones or pebbles, and this board where you have 12 smaller pots and then 2 home pots. So it's a 2-player game, and the objective of the game is to get as many marbles as possible in your home pot. So I'll explain this more tomorrow in class when I bring it in, but for now I actually wanted to use it just to quickly recap how we can model our fractions that we're learning in class today. So we're learning about addition of fractions and multiplication of fractions and a fraction of another fraction. And I thought this Mancala game would be a good way to just quickly review and review how we represent our fractions. A lot of us do know the strategy for addition. We find the common denominator. And for multiplication, you just multiply the numerators by the numerators and the denominator by the denominator. And we're all usually happy enough just using that strategy. But what I want students to really understand is what the fractions actually mean, what the expressions mean, how they can visualize them to really get a good understanding of fractions. So let's have a quick look using this game, Mancala. So say if we started with a basic fraction addition expression, and I zoom in here on these 6 pots. So we've got 6 empty pots, and if I asked for the expression, how can you model this expression? Half plus a third. A lot of us might jump to the common denominator and quickly find out the answer, but not actually understand how we could visually represent it. So we're going to look at how we model half of a third. So straight away we see this model. If it's a half, we've got 2. We've got 2 by a 3 because we've got thirds. So we draw a model 2 by 3. And now we have half of this model. So we'll see if we can find a way to represent half of these pots using our marbles. So we would go 1, 2, 3. That looks like half to me. You've just split the model in half, covering 3 in the bottom and leaving 3 up the top empty. So there's a half of our model. And we want to add on a third. So if we look carefully at our model here, we have 3 columns, 1, 2, and 3. And we want to add on 1/3. So let's add on one of these columns. Now, in fractions, we never want 2 of these marbles in the same pot. So let's put one of these into an empty one and see what we come up with. We now have 5 of these pots full and 1 empty. So the fraction of this entire whole unit here is going to be 5/6. So 5 marbles out of 6 because we have an empty space up here. So our expression 1/2 plus 1/3 is actually equal to 5/6 with 1/6 remaining. So that's just a quick way we can use Mancala to represent some fractions. If I zoom out a bit, we might do a little bit more of a difficult one. Let's see if we said 1/2 plus 1/6. That might be a little bit more trickier. So just like I said in the previous small example, usually people would say, well, let's find a common denominator and do it the old-fashioned way, where we just use the routine that we know and solve the expression. However, we want to try and model this again. So let's look at our denominators. Straight away we can see that this denominator here is 2 and this one is 6. So we would draw a model 2 by 6. And you can see our Mancala is conveniently a 2 by 6 model ready for us to use for our fractions. So let's have a look and see how we can represent half of this Mancala board using our stones. So we can see that a half will be 1, 2, 3, 4, 5, and 6. We have split this Mancala board into a half. So all of my side has marbles and the poor opponent has none. So now we have a half, and we want to add on 1/6. So if we look carefully at our Mancala board, we can see it's actually comprised of 6 columns. 1, 2, 3, 4, 5, and 6. So if we want to add on 1/6, we got to fill in our column. Just like we said, we do not want 2 stones in the one little pot. So if there's a free space, and there are 5 free spaces, let's put one in the free space. So now let's look at what fraction that we have for out of our whole Mancala board. Half plus 1/6 is going to be equal to, let's count out how many marbles we have. 1, 2, 3, 4, 5, 6, 7, 8. Out of how many actual spaces are in our whole Mancala board? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a half plus 1/6 is going to be 8 over 12. And we can actually write that as an equivalent fraction, or a fraction that looks different, but it actually is the same. If we divide both the numerator and the denominator by 4, we get 2 over 3, or 2/3. Okay, so that's a quick way to show you how to add fractions. I want to actually go on to a quick multiplication question. And if I said to you, let's just use these 4, actually let's use 5. So let's use a 5 by 2 grid. And I want to ask you, well, you know what? What's a half of 3/5? Straight away you might think, oh well, I don't know, it's not addition. It's asking half of 3/5. Straight away, if we can't think of what to do, whether it's addition, multiplication, let's simply draw out our model anyway with 5 by 2 shape. So right now we have our Mancala board. We have 2 along the side and 5 along the top. So altogether we have 10 spaces to work with. So let's see what we're asked. We're asked a half of something. So let's find what this something is, and then we'll get a half of it. So we have 3/5. So let's represent 3/5 using our model. We can see that our rows are going to be, our columns are going to be 1, 2, 3, 4, 5. So 3/5 is going to be represented. There's 1/5. Oops, put them in the wrong pot. 1/5, 2/5, and 3/5. So we now have 3/5 represented of our model here, and we want to get a half of this. So now let's look closely. If we want a half of this 3/5, let's just zoom in and focus on this 3/5 that we have and find out what half is. So half, we would simply, if we have 1 and 2 rows, we would split in half straight down the middle. So let's take out a half of this, half of this 3/5. So when we're asked to give our answer, we write it as a fraction of the whole board that we had at the start. So we had a 2 by 5 board, and we originally had 3/5, and then we wanted a half of those 3/5, and we're left with the following. So let's count them up. We're left with 1, 2, 3 out of a possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, my page is moving. 3/10. So our answer, a half of 3/5, is going to be 3/10. And that, grade 8s, is how you can represent our fractions using a model and using a math game called Mancala. Right, challenge time. It's a little bit off fractions, but I want to actually challenge you and see if you can come up with the answer or the possible solution for this over the weekend. It's a long weekend, so you have lots of time. If I start with 4 marbles, 4 stones in each of these pots, like so. Let's quickly put them in. hopefully you can follow me along now when I pose this problem for you. Nearly there. Three, four. Perfect. So we have our pots full, and we have got 4 in each pot. Moving in an anti-clockwise direction, so going this way. Your task is to see and how many moves you can move all of these marbles or these stones into the home pots. And you can move them like so. If you want to move this pot, we have to go this direction, and as we move it, we have 4 here. Every pot that you go over, a marble has to go inside. 3 and 4. So we have put 1 into our pot. Our next move may be this one. Let's go 1, and we keep moving around. 2, 3, 4, and 5. So we have some empty pots, and that's fine, but we want to find out how many moves it takes us to get all of these marbles into both of these pots. Let's try one from down here. 1, 2, 3, 4. And that's another move. Let's see if we can keep going. Let's try just this one. Move it to here. Okay, so you can see how the trend goes. So you keep moving around, seeing how many moves it takes you to completely empty these small pots and get all of your marbles in both of these larger home pots. Let's see who can do it in the least amount of moves, because it's quite the strategy and there is a bit of logical thinking to this. So let's see who can complete it in the least amount of moves, and whoever does it in the least amount of moves will get a special prize on Tuesday when we return to class. Best of luck. Have a great weekend.